Hello friends, we are going to learn concept of finding the solution of differential equation by the Euler's method and homogeneous differential equation method from the unit calculus of IBDP math AAHL syllabus, and I have taken a problem from IBDP math AAHL past paper. Now the problem here is: consider the differential equation dy by dx equals to x square plus 3y square upon xy, where x is greater than 0 and y is greater than 0. It is given that y equals to 2 when x equals to 1. A part: use Euler's method with step length 0.1 to find an approximate value of y when x equals to 1.1. B part: by solving the differential equation, show that y equals to x times root 9x power 4 minus 1 upon 2. C part: find the value of y when x equals to 1.1. D part: with reference to the concavity of the graph of y equals to x root 9x power 4 minus 1 upon 2 for x is greater than and equals to 1 and less than and equals to 1.1. Explain why the value of y found in part C is greater than the approximate value of y found in part A. The graph of y equals to x root 9x power 4 minus 1 upon 2 for x is greater than root 3 upon 3 less than 1 has a point of inflection at the point P. E part: by sketching the graph of an appropriate derivative of y, determine the x coordinate of P. It can be shown that d2y upon dx square equals to minus x power 4 plus x square y square plus 6y power 4 upon x square y power 3, where x is greater than 0 and y is greater than 0. F part: use this expression for d2y upon dx square to show that point P lies on the straight line y equals to mx, where the exact value of m is to be determined. So this is the question. Now we will start the solution. Part A, we have the differential equation dy by dx equals to x square plus 3y square upon x into y. In A part, we have to use the Euler's method. The initial values are given here: y equals to 2 and x equals to 1. As we are saying these are the initial value, so we can write here x0 and y0, and we are looking for the probability value of y when x equals to 1.1. The step length given, that is 0.1. So now we are looking for y1 equals to y0 plus step length into f of x0 and y0. We have the value of y0, which is 2 plus 0.1 into so that is x square, so 1 square plus 3 2 square upon 1 into 2. Now with the help of calculator we will find out the answer here. Menu, add calculator. 2 plus 0.1 into 1 square plus 3 into 2 whole square upon 1 into 2, and the answer would be 2.65. So we can write y 1.1 equals to 2.65. So this is the solution of A part. Now we will proceed to B part. In B part, by solving the differential equation to show that y equals to x times root 9x power 4 minus 1 upon 2. So dy by dx equals to x square plus 3y square upon x into y. Now since here this is x square, y square, and here also we have the power 2, hence the equation is known as homogeneous equation. So we can write here, given equation is homogeneous so we will be using the method y equals to vx. So dy by dx equals to v, we will apply the product rule. So v into 1 plus x into dv upon dx. Now in the given equation we will write v plus x dv upon dx equals to x square plus 3 v square x square upon x into vx. So v plus x dv upon dx equals to, we'll take x square common, so 1 plus 3v square upon x square into v. We will further simplify because x square and x square cancel. So 1 plus 3 v square upon v. We can simplify further. So x dv upon dx equals to 1 plus 3v square upon v minus v here. So we will simplify this. V and v will multiply, become v square. So we will be getting here 1 plus 2v square upon v. Now by method v upon 1 plus 2v square dv equals to dx upon x. Now here we will apply the method of integration by substitution. So let 1 plus 2v square equals to say t, then 4v dv equals to dt. So v dv upon dt by 4. So we will substitute here 1 upon 4 integration and v dv, so that is dt upon t equals to integration dx upon x. So we will get here 1 by 4 ln, and in place of t we will be writing 1 plus 2v square equals to ln x plus c. So we will replace our v. So 1 upon 4 ln 1 plus 2. We have taken here y equals to vx, then v equals to y upon x. So we will be getting here y square upon x square equals to ln x plus c. Now the initial condition given here, x equals to 1 and y equals to 2. So we will write here 1 by 4 ln 1 plus, now in place of y I will use here 2. So 2 square is 4, 4 into 2 8, and denominator would be 1 equals to ln 1 plus c. So we will be getting 1 by 4 ln 9 equals to c, as the ln 1 is 0. So the final answer we will be getting here would be 1 by 4 ln 1 plus 2y square upon x square equals to ln x plus 1 upon 4 ln 9. Now we will do the simplification because we need to make a y subject. So we will start simplifying that. Ln 1 plus 2 y upon x whole square equals to 4 ln x plus ln 9. We can further write ln 1 plus 2 y upon x whole square equals to, you can write here ln, and here we can write 9 x power 4. Now the ln and ln will cancel from both sides, and we will be getting here 2 y upon x whole square equals to 9x power 4 minus 1. Further we can write y upon x whole square equals to 9x power 4 minus 1 upon 2. And then we can write here y equals to 9x power 4 minus 1 upon 2, then the square root into x and plus minus. But as the condition given y is greater than 0, so we will be taking here y equals to x square root 9x power 4 minus 1 upon 2. So this is the solution of B part. Now we will proceed to C part. In C part, find the value of y when x is equals to 1.1. So substitute x equals to 1.1. So y equals to 1.1 square root 9 1.1 power 4 minus 1 upon 2. Now we will use calculator to find out the answer. So the answer is 2.714. 2.714. So this is the solution of C part. Now we will proceed to D part. With reference to the concavity of the graph of y equals to x root 9x power 4 minus 1 upon 2 for x is greater than and equals to 1 and less than and equals to 1.1. Explain why the value of y found in part C is greater than the approximate value of y found in part A. So now the solution would be, as it is written concavity, so d2 y upon dx square is greater than 0 for 1 greater than and equals to x less than and equals to 1.1. Hence, tangent drawn using Euler's method gives an underestimate of the true value. So the value of y when x equals to 1.1 is greater than the approximate value found in part A. So this is the solution of D part. Now we will proceed to E part. The graph of y equals to x root 9x power 4 minus 1 upon 2 for x is greater than root 3 upon 3 less than 1 has a point of inflection at the point P. By sketching the graph of appropriate derivative of y, determine the x coordinate of the P. So now we will use calculator and then we will sketch the graph of the function as well as its derivative and second derivative. So this would be the graph of function. Now we will make the graph of derivative and second derivative. So this is the graph of derivative. Now we will find out the coordinate of the point here. So the value of x would be 0.656. So x equal to 0.65 and 6. The graph which we are getting like this, and this point coordinate is so this is the answer of E part. Now we will proceed to F part. It can be shown that d2y over dx square equals to minus x power 4 plus x square y square plus 6y power 4 upon x square y power 3, where x is greater than 0 and y is greater than 0. Using this expression to show the point P lies on the straight line y equals to mx, where the exact value of m is to be determined. So we will be writing here d2y over dx square equals to minus x power 4 plus x square y square plus 6y power 4 upon x square y cube. As the P point is a point of inflection, hence second derivative would be 0. So d2y over dx square we will consider 0, and then therefore we can write here minus x power 4 plus x square y square plus 6y power 4 equals to 0. Now we will divide by y power 4, so minus x upon y power 4 plus x upon y whole square plus 6 equals to 0. Let y upon x equals to m. So we can write here minus 1 upon m power 4 plus 1 upon m square plus 6 equals to 0. We can write 6 m power 4 plus m square minus 1 equal to 0. Let m square equals to say t. So you can write 6t square plus t minus 1 equal to 0. So we can find here the factor 6 into 1, 6. So 6t square plus 3t minus 2t minus 1 equal to 0. So 3t we will take common. So it would be 2t plus 1 and take minus 7 common. So it would be 2t plus 1 equal to 0. So we will be getting here 3t minus 1 and 2t plus 1 equals to 0. So as we know that the t is equal to m square, so we can write here m square equals to 1 upon 3 and m square equals to minus 1 upon 2. So minus 1 upon 2 we cannot consider because square root of negative number is not possible. So we will be getting here m equals to plus minus 1 upon root 3. So line would be y equals to 1 upon root 3 x as x is greater than 0, y is greater than 0. So m would be greater than 0. So value of m would be 1 upon root 3. So this is the solution of given problem. I hope you understood this solution. Please like, share and subscribe this channel.